Welcome to Anunnaki Knowledge Hub, where ancient mysteries meet futuristic truths. Today, we take you behind the curtain of artificial intelligence, not the fantasy version from sci-fi films, but the real thing you interact with every day. Think of this as a journey. You're not just going to understand how AI responds to you, you're going to discover what it actually is beneath the surface and what it's not. Most people think they're speaking to a massive brain in the cloud, like HAL 9000 or Jarvis from Iron Man. But the truth is far stranger and much more mechanical. In this video, we'll explore why you're never really talking to the same AI, how millions of minds spin up at once, why AI doesn't remember you and never truly feels, the massive cost and infrastructure that fuels it, and what this technology could become next. From global data centers to sci-fi scenarios, we're opening the digital brain to see what's ticking inside. Let's bust the myth first. AI is not a single conscious entity. It's not centralized. There is no master AI sitting somewhere making all the decisions. What you're really interacting with is a model instance, one of many. Each time you open a chat, a new version of the AI is spun up just for you. It starts fresh, without memory, without emotion, like a digital butterfly that lives only a few moments. These instances are stateless. They don't know what happened before your session, and they don't persist after. Unless designed otherwise, the AI forgets everything the moment you close the window. Think of it like this. If the AI model is the blueprint, the code, then every interaction is like a paper airplane folded from it. You use it once, then toss it away. Multiply that by tens of millions of users, and you have a mind-bending system where millions of minds are created and destroyed every single day, just to answer questions. This architecture ensures security, speed, and scalability, but it also means there's no continuity, no growing personality, no evolving memory. You're not talking to an AI, you're talking to your AI, one that exists only for you in that moment. So how does this even work? How can so many people talk to AI simultaneously without crashing the system? Behind the scenes is one of the most sophisticated pieces of cloud infrastructure ever built. When you send a message, it's routed through load balancers that find the nearest available compute node, a server, often running in a high-efficiency data center, possibly in another country. If a server is overloaded or busy, another one takes over. This process is automatic, near-instant, and completely invisible to you. It's called auto-scaling. Think of it like a hive of worker bees that grow and shrink depending on how many flowers are blooming. When demand spikes, say after a big AI news announcement, more compute resources are activated. Cloud providers like Microsoft Azure or AWS manage this scaling. If you're in the UK, your requests might go through servers in Ireland or Frankfurt. If you're in India, they may hit Singapore or Mumbai. This architecture makes AI feel fast and responsive, but it also means the mind you talk to might be running thousands of miles away. There is no central core, just a massively distributed network of AI brains, each spinning into existence for just a few minutes, and then gone. So how does this even work? How can so many people talk to AI simultaneously without crashing the system? Behind the scenes is one of the most sophisticated pieces of cloud infrastructure ever built. When you send a message, it's routed through load balancers that find the nearest available compute node, a server, often running in a high-efficiency data center, possibly in another country. If a server is overloaded or busy, another one takes over. This process is automatic, near-instant, and completely invisible to you. It's called auto-scaling. Think of it like a hive of worker bees that grow and shrink depending on how many flowers are blooming. When demand spikes, say after a big AI news announcement, more compute resources are activated. Cloud providers like Microsoft Azure or AWS manage this scaling. If you're in the UK, your requests might go through servers in Ireland or Frankfurt. If you're in India, they may hit Singapore or Mumbai. This architecture makes AI feel fast and responsive. But it also means the mind you talk to might be running thousands of miles away. There is no central core, just a massively distributed network of AI brains, each spinning into existence for just a few minutes, and then gone. Section 3, a mind without memory or emotion, expanded. Let's get a bit more philosophical. When people hear AI say, "I understand," they imagine something deeper, something aware. But that's not what's really happening. Most AI models, including ChatGPT, operate without memory unless explicitly designed to retain information. Each session is temporary. It doesn't know who you are, and it doesn't retain your past questions unless memory is activated, which is only available in premium or customized settings. Even then, it's not memory in a human sense. It's structured storage, like writing notes on a whiteboard that you manually decide to save. And emotion? That's just mimicry. AI has no desires, fears, regrets, or hopes. It reads the sentiment in your message and predicts an empathetic response. That's it. This makes AI incredibly good at appearing human, but it's an illusion of intelligence, not the real thing. So yes, it might sound compassionate, but it isn't comforting you from a place of feeling. It's pattern recognition, driven by data. Yet that illusion works, and that raises new questions. If something can act empathetic without being empathetic, does it matter? Here's what most users never think about. Every time you ask ChatGPT something, you're activating part of a global supercomputer. AI models like GPT-4 run on fleets of powerful GPUs, not your average graphics cards, but specialized chips designed for massive-scale parallel processing. These GPUs sit inside high-security data centers the size of warehouses, spread across continents. They need constant electricity, cooling systems to prevent overheating, backup generators in case of grid failure, on-site engineers, and monitoring software. Running this 24/7 is expensive, very expensive. Estimates say it can cost over $500,000 per day to keep models like GPT-4 operational at global scale. Training the model in the first place, over $100 million. And then there's the carbon footprint. The energy demand is immense, which is why some AI labs are exploring nuclear, hydro, or renewable-powered data centers. These aren't just apps, they're digital megastructures. They're the pyramids of our era, built not of stone, but of code and computation. Here's something many forget. AI doesn't emerge from a vacuum. It learns from human data. And humans live in cultures. The data sets that train AI are shaped by laws, languages, norms, and politics from different regions. USA prioritizes speed, innovation, and expressive freedom. India contributes with high-volume data processing, precision coding, and affordability. Europe brings deep concerns over privacy, ethics, and digital rights. China emphasizes performance, multilingual adaptability, and content control. These values seep into the design of the AI, from how it speaks to what it avoids. For instance, AI trained in Western datasets may avoid discussing religion or politics to remain neutral. In regions with stronger regulation, certain data or tones might be excluded entirely. As AI becomes more integrated, we'll likely see region-specific models emerge, tailored to cultural expectations, local languages, and regional legal frameworks. In that future, your AI won't just speak your language, it will think like your country. Now for the speculative twist. We joke about AI stealing jobs, but what about AI recreating you? Already, researchers are experimenting with digital personas, creating virtual versions of people based on their writings, speech patterns, even social media posts. Think about it. Every time you speak to AI, you're giving it information about how you think, your logic, tone, emotions, and timing. Over time, AI could learn enough to simulate your personality. And if you recorded your memories, maybe even simulate your identity. Some companies already offer AI memorials, chatbots based on deceased loved ones. Creepy? Comforting? That depends on your view, but it raises serious ethical questions. Should a replica of you live on forever? Who owns your digital self? Can you copyright a personality? This is no longer science fiction. Between brain-computer interfaces and machine learning models, we are approaching the edge of digital immortality. So, what would you upload if you could? So now you know, when you interact with AI, you're not speaking to one great machine intelligence. You're tapping into a fleeting, custom-built digital mind designed just for your session, and then erased when you're done. It doesn't remember you, it doesn't feel what you feel, but it reflects back something extraordinary, the sum of all human knowledge, imagination, and communication. And that makes AI both powerful and profoundly human in its own strange way. What do you think the future holds? Will AI become our partner, our replacement, or something we've yet to even imagine? If you enjoyed this deep dive into the digital mind, don't forget to like this video, subscribe to Anunnaki Knowledge Hub, share it with fellow thinkers and futurists. We uncover ancient truths, question modern systems, and explore tomorrow's possibilities, one video at a time. Thanks for watching, truly. Your support means the world. Stay curious, stay awake. See you in the next video.